top left, right, fill in. And also I should find just your names, looking on. All right, Lana, which one is the bell-shaped dot plot? F, yes, I believe that was like the one we did in class, so hopefully everyone got that. And it's my recommendation that you have more than just the letter. All right, but I recommend you at least sketch it. Or if you have the means to like cut it out and paste it, I would recommend that too. But bell shape should look like a bell, if you will. Like the data has a peak in the middle and then it kind of tapers out. And that's our dot plot example. Let's see, Cameron S. Which of these options would be our skewed right dot plot? Remember, we already used that, so don't pick up. Our skewed right dot plot. H, good. Where do I tell you to look so that you get the name right? Circle void. Don't look at where the data is clustered because then that will confuse you. Look for where the void is, which is on the right. That means that H is your right skewed dot plot example. So H was right skewed, and maybe it doesn't need to look perfect, but it should definitely look where there's like a space on the right. Okay, question? Yes, make sure you sign out. Ivory, what about our skewed left dot plot? I, correct. So this one is skewed left because it has a space like a void on the left. G and J are called something different, but they are also box plots. So skewed left would have most of its data to the right and like a clear space on the left. Now, maybe I'll wait till we get to the histogram, but start thinking about what these, I don't know what you want to call it, outliers, if you will. They might not actually be outliers, but these ones that are farther from the data, think about what that does to the mean or the meaning. Okay. Amy, which dot plot would be our bimodal? J. What does the prefix bi mean? So you should be looking for two peaks, basically, and I have that here in J, so that is why J is our bimodal. Looking for the two peaks. Is the bimodal symmetric, class?
No.
Well, I could draw a line of symmetry down here, it looks like, and that would be my middle. It does look perfectly symmetric. So maybe while we're on that one, scroll down. When it's bimodal, it is symmetric. You can just say yes, because it says, is it symmetric? Okay, so then by process of elimination, which dot plot should be our uniform dot plot? Cadence? G. Because it has equal height. It could have also been where all the data points are one number, two, or it just makes like an even shape, a uniform shape. So G was. Any questions on that? Okay. So then, Austin, which histogram best displays a bell shape? C. Best displays a bell shape histogram. So that would go there. Remember, histograms have to have it where their bars are touching, unless there's a gap in the data. That does happen sometimes. But for a bell shape, there shouldn't be any gaps in the data. And what else is characteristic of histograms? Like what makes them not just like a bar graph? What? So it has intervals, in other words. And I don't know if these are the intervals from that page, but here's an example. It could be labeled to where it's like this one's 0 through 4. It could be labeled like that. Or it can be labeled like where it's like 0 here and 5 here, but this bar is still 0 through 4. Once it hits that higher number in the data set, like 5, it goes here. And then here would be 10 if it's labeled that way. These are still intervals of 5. If that makes sense. Questions? Do we have a question? I thought I saw a hand. Okay. So then, Wade, which histogram would be our skewed right is next? Which ones are skewed right histogram? Okay, me too. There's more of a space on the right. Guys, pay attention. I'm not doing this for me. I already know all this stuff. There is a gap in the data, but that doesn't necessarily make this bimodal, okay? It's where there's less data on the right, therefore B is skewed right. Dan, what about our skewed left histogram?
I think it's D.
Okay, I would agree. So this may or may not be an outlier, but whenever things are skewed, it's probably because an outlier. The reason why I say maybe is because there's like a mathematical formula we learned, right? But you need to know that outliers pull the mean in that direction. Okay, so for my skewed left examples, would I expect, don't say it yet, like just think about it. Would I expect the mean to be higher than the median or the median to be higher? Think about it. If outliers pull the mean in that direction, would I expect the mean to be higher or lower than the median? So raise your hand if you think the mean would be higher. Raise your hand if you think the mean would be lower. Okay, think of this conversation when you take your test, okay? The mean is lower than the median in this one, even though, like we said for histograms, we don't know what the actual data is, we just know the shape. We know the mean is lower because the outliers is pulling the mean down. Make sense? Numbers to the left on the number line are smaller. So then for this one, stay with me, that has maybe some outliers here on our skewed right example. Would you expect the mean to be higher or lower than the median? Raise your hand if you think the mean would be higher than the median. Okay, you're right. For this one, our mean would be higher because our outliers are pulling the mean higher this time. So it's on the higher end of the data. Make sense? Maybe. So mean higher than median when it's skewed right. Because the mean is affected by outliers. Outliers pull it in that direction. Like if I took a poll of all of your guys' ages and then I included mine, it would pull our average up, right? Even though you're not probably 16 or something. That's what would happen. Okay. All right, moving on. Aiden. Let me see what's next. Hold on, don't tell me yet. The skewed left was D. So then, Aiden, which of these is our bimodal histogram? Good. 2 peaks. It's like the inversion of this. Okay, so bimodal is opposite of bell shape. Are these both symmetric, bell shaped and bimodal?
Yes.
What's the mean of, well, let's not after that. So since they're both symmetric, the mean would be toward the middle. one thing you'll be asked on your test is which of these is more spread out. Think about it, don't say it yet. Compare C and E. Think about which one is more spread out. Raise your hand if you think C is more spread out. Raise your hand if you think E is more spread out. Okay, why E? Why is E more spread out than C? Steven,
Oh, sorry, right, what was it?
or sorry, Dan?
I think E because it's like the 2 point, there's like 2 tall points and it's like away from each other.
Okay, I agree. When the data is symmetric, so here's another way to think about it. When the data is symmetric, where is the mean? In the middle, right? So in E, we have most of our data far away from the mean. And in C, we have most of our data near the mean. So if you're choosing which one's more spread out, you use more spread out. Okay, good. I'm giving you gold here, so. Try to understand. So E is bimodal. Let's see, Massimo, which one is our uniform histogram? Okay, good. Our last histogram. All on an even level. Okay, box plots are a little more tricky, but if you could identify the correct dot plot, I figured you could just type that into Desmos and maybe connect a correct box plot if you needed to. So Jalen, for our first box plot example, which one looks bell-shaped to you? N, I would agree. And N can probably work for something else on our list too, but you wanna like use everything once. So N is the most bell-shaped out of our options, okay? Questions on that? Would you say that it was symmetric, that box plot we looked at?
Yeah,
Yeah, if I draw my line of symmetry down the middle, it looks like a mirror image. So it is symmetric.
Okay.
We mentioned this in class. So I'll rewrite it, but it is symmetric, all of those distributions. So we prefer the mean. When we prefer the mean, do we prefer standard deviation / MAD or IQR?
standard deviation slash mean.
Okay, good. The way that I remember that is that you need the mean to calculate these, so like they kind of are grouped together. Good. Okay. So then Sophia, for our right skewed box plot, which one would you say is right skewed? It would be O. In our box plot, you could see the quartiles really easy. Our quartiles split the data into quartiles split the data into how many parts? 4 quarters, like how there's 4 quarters in a dollar, right? Our quartiles split the data into quarters, so like here's quartile 1, quartile 2, and quartile 3. That means here's my first 25% of data that's pretty close together. Our second 25% also close together. Third 25%. And then our fourth 25% that's more spread out. So yes, this would be a right skewed box plot. There's, I don't want to say less data over here, but if it was a dot plot, there would be less data over here. Okay. Skewed right is better. Oh, weird. Let's see, Cameron B. Which one would be our left skewed box plot? Okay, good. It's like the opposite of our right skewed one. This one has it more spread out on the left. So L is our left skew. Okay, now here's the tricky one. Let's see, Gavin. Which box plot would be our bimodal box plot? So what I did, aside from just Google bimodal box plot example, I found a bimodal piece of data, typed that into Desmos, and it did make a box plot that looked like this. Where I guess the minimum and maximum match the quartiles. So this one is our bimodal. So I'll put that over here. Which means by process of elimination, the uniform box plot would be. Okay. Which I know looks weird. The uniform box plot could either look perfectly symmetric like this. Or this one's like where all my data was 5. So that's another example of uniform. And this is the box plot. Questions? Okay, almost done. Stay with me. Charles, mean or median when it's skewed right? Median. Because the outliers pull it in that direction. So that's why we prefer the median. Outliers really affect the mean. When we prefer the median, Chris, do we prefer standard deviation or MAD or IQR? IQR, whenever you prefer the median. I think about it like our box plots, especially, you can see the median, you can see the quartiles, what you need to do your IQR. So that's how I remember that those go hand in hand. Let's see. Max is skewed data symmetric. Okay, no here. Questions on that? All right, so skewed left data, class all at once, mean or median? When we prefer the median, what do we prefer? Okay,
IQR.
good. Is skewed symmetric, yes or no?
No.
Okay. Glad we know that. Bimodal, is bimodal distributions
Me,
symmetric?
no, yes, sorry, yes.
Okay, therefore, should we use mean or median?
Me,
And should we use what for spread?
standard deviation. Slash nine.
Okay, good. Last one is uniform data symmetric.
Mean.
Therefore, should I use mean or median?
Mean.
That's kind of the order you should be asking yourself.
Standard deviation.
And then because we use mean, we're using. Perfect. Any questions?
No, ma'am.
So now you know, because everyone else, I'm just telling to check online, and hopefully they'll ask me questions if they have questions. But now you guys should know why these are the answers. I think class ends at 11:35. I'll check when I get back to my desk. So that gives you 10 minutes to maybe make sure you have your binder ready for Friday. Maybe do your assignments before that deadline next Monday. What else? What else should you do? The study guides and Schoology, but I don't want to see you just sitting around playing games or whatever. You have 10 minutes to do something productive for math.